We've got 2016 one here. Maybe 2016 one's a better one to look at. Give me a second, Alex. I'll just I'll photocopy this for you. Got enough time. You won't have time to do the whole thing, but pages. Right. Anyone else coming in, or you don't know?
I think stands in the. I think there's a music exam.
Oh, yeah. I've got 3 watches now, so maybe I've got a couple of them ready to roll. Let's do it. I'll do a live one. Because I stuck it on the Google Classroom that I was going to do this again. Here you go, Alex. So, looking at the 2017 chemistry exam, no, 2016. So, good question 1 to start off with. Here you go, mate. Have a go at that. And we'll try. Just adjust this camera here. Sweet. So for question 1 here. If you guys who are watching, Oh, hey, John, you're there again. Good to see you. Oh, here we go. Hello. For... Yeah, sure. I'm doing it online as well as here. So.
Oh, okay.
Yeah.
Because she just texted me and said that it wasn't open until 11:30 to 12.
Oh, in class, it's open to 11:30 to 12.
Okay.
But Alex is here anyway. But
yeah.
If she wants to jump online now, I'm doing some stuff online.
Yeah, I'm not sure because she's just trying to get a ride here and a ride back and back to the exam. So I'll tell her she can come now or 11:30.
Yeah, or online anyway.
Yeah.
Sweet.
Okay.
Cool.
So you prefer 11:30 in the class?
Oh, yep.
Okay.
So yes. So we got 6. So we got 6 here, which is to Hicks. Ido group 2. Two iodohexane. Is that what you got for your first one, Alex?
Yeah.
Sweet, easy. Next one is a pentanoic acid, 3 methyl. So we've got 5 carbons. Oh, my mistake. There you go. I've got second one. You've got 5 carbons in the chain, COOH. Yep, cool. You can have your methyl group going up or down. It doesn't matter. But-1-ine. We've got 4 carbons. 1, 2, 3. Yeah. So you got your triple bond, eh? For but-1-ine. Yep, and it doesn't matter which end you have your triple bond, you can have it either end, as long as you don't have any extra hydrogens coming off this carbon. That's where you'll get unstuck. And this last one, got the NH2 group on the end, which makes it a amine, so it's just, you can have 2 names for this. Propane 1 amine, or 1 amino propane, or just amino propane. I'd stick with propane 1 amine. What did you call it? Okay. Yeah, I'd stick with propane 1 amine just to be on the safe side, but probably doesn't matter. Sweet. Oh, this is a good one. 3 constitutional structural isomers of C5H12. So remember, we start with just our 5 C's in a row. And we have to name it. Draw all our H's. All single bonds, so that's pentane. Next one, chuck 4 C's in a row and stick a methyl group coming off 1. Any questions? Stick them on the questions there. So we've got 1 methyl group, 4 in a row, so it's 2 methyl butane. Got that? Good. 2 methyl butane. Sweet, you got it there. 1 at each end. The last one. 1, 2, 3. 1 up. 1 down. All the H's. And that's 2, 3, 5, 2, methyl propane. You guys are watching, remember, so I start off with my 5 in a row, then I do 4 in a row, put a branch on, I'll put that branch here, here, or here, it would still be 2 methyl butane, so that's it. just got 3 there, Alex. What's the other one you got?
It's 2 ethyl wait.
Let's have a look at it. Where? This one here?
Yeah.
But remember, this is the longest chain here, so 1, 2, 3, 4, so it's still the same as that one. Oh, sorry. My audio's coming better. Thanks, John. Over the page. Classification of haloalkanes. Easy. So here's my haloalkane group. So classify. Oh, it's so easy. First one, there's 1, 2, 3 carbons coming off that carbon, so it's tertiary. Here's my halogen. This is a trick one. The second one, there's only 1 carbon coming off it, even though there's that second one. Did you just get that right, Alex? Yeah, good. It's still a primary, but just be careful of that because it's done that to trick you. There's only 1 coming off. There's only 1 there, even though it looks like 2. And this last one, I've got 2 coming here and here coming off this carbon. So that's secondary. All good? Hopefully you guys are watching this understanding that. Great. Save it, Olivia. Question 3, have a look at this and then I'll start it with you in a second. There you go. There's 2 sides. There's the second part to it, Alex. So this is the one that's, I know everyone seems to find these flow diagrams a bit of a challenge, eh? It's worth having a look at this. So complete the flow chart by drawing the structural formula for the organic compounds A, B, C, D and identify reagent X. First one, super easy. We're putting that PT stands for platinum. What is it? Platinum's a catalyst, cool. H2, you add 2 hydrogens. Your only option is going to be the double bond breaks. And you get, do you have to name them? It doesn't say we have to name them, but to be on the safe side, you probably should name them. So this first one here is ethene. The second one, it becomes ethane. Then it reacts to form bromoethane. Bromoethane or 1-bromoethane. So what you got? Then with the KOH, the K joins with the Br. What else? What do you get, Alex?
Alcohol.
Good, because it's aqueous. Remember, when you react potassium hydroxide and it's an aqueous solution, it will become an alcohol. If the KOH was alcohol, then it would become a
An alkene?
yes, it would become an alkene because the H would go with the OH to make a H2O, and the Br would go with a K. So yeah, so you end up with simply this. So this is easy. Just remember that, guys. I've said this 100 times. Aqueous means it will form an alcohol. KOH, aqueous, forms an alcohol. And lastly, C2O7. What's that last one going to do? Dichromate. It's an oxidizer. What did you get, Alex? Carboxylic acid. Good, because it's a dichromate. So you end up with C, double bond O. OH is there. So we name that one there. That's ethanol. And this bottom one is ethanoic acid, otherwise known as vinegar. So reaction 1, we have to name the types of reactions. First one, we've simply got an H being swapped for a Br, so that's a substitution reaction. The second one, we've got a Br being swapped for an OH, that's also a substitution. Don't get fooled by that one. Because even though with this one you get an extra atom, it's because the group is swapped that we just consider it a substitution. So even though this has got, an extra atom compared to that, it's the group, so we don't call it an addition. And the last one, what do we call that last one?
I think it's not a substitution because it doesn't create a double bond.
We can consider it an elimination because we do. A double bond is created between the C and the O though. But is there a special name for what we're calling the formation of a carboxylic acid? It's not a neutralization. Oxidation reaction. It's an oxidation reaction, but you might also call it like an elimination. We've added an oxygen. Sweet, over the page. You done all this? Polystyrene is a polymer with the structure CH2, C, H, C6H5. So remember, this is a condensed structural formula. Each one of those, that's C, H there, C with H there, and then we've got a big chain of C6, H5, and then it carries on. So the monomer used to make this polymer, that's going to be the double bond here, so it's going to be double bond, H, C, H, C6, H, 5. What did you draw for that one, Alex? So what you drew? Yeah, that's probably okay what you've done, but just to be on the safe side, you could draw it like what I did. You've done the condensed structural formula. This last one. Explain why the formation of polystyrene from its monomer is classified as an addition polymerization reaction. 2 key words. It's an addition reaction because we're adding a whole lot of molecules. And it's a polymerization reaction because we're making a polymer. So for answering that, Alex, you just say something like it's an addition reaction because double bonds are broken and extra atoms, molecules are joined up. So the key thing is the double bonds are broken, leaving space for stuff to get filled in. And it's a polymerization one because you're making a polymer. So it's like real self-explanatory. And it's good to probably define what a polymer is. A polymer is a long molecule made up of many repeating units. I don't know if you can see that. So poly equals many, mer equals units. Sweet. There you go. Right. Have a look at this one, you guys. Still there. You can read that. The reaction between propene and hydrogen chloride produces a mixture of products. So let's draw it out in full. C3H6, I'm going to draw it. Double bond, H, H, H. And we're adding hydrogen chloride. So we've got two options here. So this one here, double bond breaks. And the chloride goes there. More double bond breaks and the chloride goes there. So it can go here or here. So this is 1 chloropropane, 2 chloropropane. Those are your two options. Which one's the major? Good, this one here is our major product. Because the rich get richer, this guy here, who originally had 2 hydrogens, got the extra hydrogen. So draw and name the major and minor products. So the major product, put it here. Sweet, Ayla. Ayla, if you wanted to come in, I'll be here at 11:30 to do some in-class revision. And minor. Doesn't matter where you put that Cl. It could be at either end, as long as it's on number 1. 1 chloropropane. Elaborate on the reaction. What kind of reaction is it, Alex? It's an addition reaction. There's the bell. And you talk about Markovnikov, etc. Rich getting richer, blah, 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 blah. All good. Right. That's it for now. See you guys at 11 if you're coming for your exam, and good luck this afternoon. Ka kite ana.